In this video, we're going to look at stone mastic asphalt in a little bit more detail. Stone mastic seal, or SMA for short, has a large proportion of coarse material, with the rest of the volume being fine materials and binder. The high coarse aggregate content means that there is more stone-on-stone contact between the coarse aggregate particles that carry most of the load. The support for the coarse particles is provided by the binder and some by the fine aggregate, which are designed to fill the voids between the coarse particles to provide better support. The binder supports the coarse aggregate particles better than the fine aggregate. Therefore, an SMA has a higher proportion of binder and fines than other asphalts. This makes it much stronger than the densely graded asphaltic concretes. The fines and binder filling the voids make the surface impermeable and so provide a higher level of waterproofing. Designing and laying an SMA takes more experience and skill than laying other asphalts, as it is very easy to get the proportions wrong and end up with too much binder on the surface, resulting in a loss of surface texture and loss of skid resistance, as well as having a surface that will wear away quickly. Too little compaction can result in air voids in the mix, which makes it permeable. The degree of skill required and the extra binder mean that SMA surfaces are more expensive and more difficult to construct, and so only justified for high traffic areas. Stone mosaic asphalt comes in several different mixes, which are designated by SMA, followed by the coarse aggregate maximum particle size. For example, SMA 14 is a stone mastic asphalt with aggregates up to 14 mm in size. You can also get SMA 7, maximum size 7 mm, and SMA 19, maximum size 19 mm. The requirements for stone mastic asphalts are also set out in NZTA M10 specification for dense graded and stone mastic asphalts. The requirements are very similar to that for chip seal chips, in that the aggregate needs to have angular particles, crushing resistance above 230 kilonewtons, which is the same as for sealing chip, weathering index AA or BA, 1% maximum of weak particles, particle shape, that is the average greatest dimension over the average least dimension of a maximum of 2.25, and a rough microstructure. This graph shows the grading envelope of an SMA 14 mix. This graph looks different from the previous grading curves we have looked at. Basically, there is a big dip in the middle. This shows that the grading is not uniformly graded or well graded. This type of curve is called a gap graded, as there is a gap in the aggregate used. In this case, the proportion of coarse sand allowed is significantly lower than the amount of fine gravel, the next size up. You can see that only 30 to 55% of the aggregate is allowed to pass the 9.5 mm sieve, which means 70% to 45% of the mix has to be 9.5 mm or larger. The densely graded asphalt grading curve we looked at had 70 to 90% being able to pass the 9.5 mm sieve, indicating that 30 to 10% of the mix weight is 9.5 mm or larger. The curve also showed a wider range of aggregates being accepted. So this curve shows an aggregate with a high proportion of coarse particles, hardly any coarse sand, and quite a bit of fine aggregate. As mentioned, the support of the coarse particles is largely provided by having more binder in the mix, which fills in the voids.